on 4 polling questions during the presentation. If you want CPE, you have to answer at least 3 of them. If you fail to click on any button on those polling questions, you will not get your CPE. You don't have to answer it right. You just have to show that you're breathing. Your credits will be available in about 7 to 10 days. If for any reason whatsoever, technology or otherwise, we are not able to complete our full 15 minutes of the presentation, the CPE will not be issued, and you can complain to me all day long and there's nothing I can do about it. So that's it. With that, I hand it off to Lance and our program. Thank you guys so much for attending. And once again, remember our sponsors.
Thanks again, Eric. Really excited about the panel that we have today. Really some industry leaders in Industry 4.0. First, we'll hear from Mark King. He is the chairman and CEO of Micropack Industries. They're a public manufacturing company in Garland, Texas. Micropack is a specialized electronics company that serves military, space, medical, and the industrial marketplace. Mark has been personally responsible for implementing many Industry 4.0 initiatives at Micropack, some of which he will share about. And they've drastically improved productivity and quality. And then next we'll hear from Clay Kerr, and he is actually a vendor of mine that he owns Sterling Fabrication Technologies, and they are a rep for Trump sheet metal fabricating equipment. They represent from Texas to California. Trump is the largest manufacturer of sheet metal fabrication equipment in the world, and they are the most, without a doubt, the most innovative of all their competitors. He's going to show you a little bit of the Smart Factory, which is casts a vision for companies like myself, a sheet metal manufacturer, that gives you the full idea of what Industry 4.0 to the max could look like. So it's really, really cool. And then last and certainly not least, we'll hear from Chris Tedford. He's the founder and COO of True Velocity. He's responsible for developing the most innovative and accurate bullets in the world. And he has now implemented a fully automated manufacturing facility in Garland. He also is the third generation owner, of a company called Automatic Products Incorporated. They are a provider of precision machine products for defense and a lot of other industries as well. So he will be able to speak a lot to, he's got the True Velocity side, which is fully automated Industry 4.0 to the max. And then he's also got his job shop, family business that is making the journey, but when you're in the higher mix variety, you can't do all the things that he's able to do on the True Velocity side. So all that to say, they just give you a little bit of summary, and I will hand it off to Mark King.
Okay, welcome everybody. I guess I should start by saying that 2 of the sponsors tonight, Roach Howard, I saw Dirk's name there, and Whitley Penn, are both support Micropack, and they are top shelf. They do an excellent job for us on the accounting side, auditing side, as well as the insurance side. So I'd highly recommend both of those corporations for your support. I wanted to start off and just kind of have a conversation about Industry 4.0 and in particular explain what it is. But first, I wanted to tell you where I'm coming from. And this is a portfolio of some of the products that we do at Micropack. And you will see that we have some lower volume business. We also build components that are not really super high volume, but reasonably high volume that automation is begging to be implemented. And so as a result of that, we do a lot of trade-offs of building by hand versus building by automation. And when you're in that role, you really have to be careful about knowing what you're getting into when you start to implement some of the advantages of Industry 4.0. Just some of those products, don't need to go through them. I just wanted to express that fundamental concept. If you go on to the next slide. So, there's a lot of definitions out there of what is Industry 4.0. So think of the industrial revolution we talk about, and they break it into four major, almost in decades. But the first was probably when we started to use assembled parts into muskets. And so the first industrial revolution was basically using piece parts and assembling those together. The second one was when mass production hit. That was sort of think of the Ford Model T. The third was when automation started to come into play, mass production lines, things that you would see primarily in the higher volume applications. And then we'll come to 4.0, and it's not really a big bang 4.0s here. It's really an evolution of integrated technology. So think of this, Industry 4.0 is the ongoing automation and data analytics integrated together to provide advanced manufacturing methods. And the second paragraph are terms that you all know about, probably even maybe experts in. Those are the technologies that are going in following Moore's law and above in terms of being implemented in today's manufacturing facilities. You've all heard about the Internet of Things. Additive manufacturing is really exciting. It doesn't yield as much into high volume applications, but it's extremely important as we go through the analytical simulations and the ability to go directly and digitize from say a drawing to a piece part. I think you know or have seen that application. Big data analytics is huge right now. The ability for us to collect data is in sensing data, process controls all across the board is really amazing. You all experience this in your everyday life. Some terms, some people like to term this as cyber physical production systems. Somebody had to give it a name with cyber in it, and that's what it came up with. It's all about automated smart factories. And I want to say something about artificial intelligence. I worked on AI back in the 90s. It was still neural networks and a lot of coding involved. Today, it's real. It is here. It has arrived, and it's available to us. Just look at what Tesla is doing with their interaction. I mean, let's be honest with ourselves. How many of us, say even 20 years ago, could sit in a living room and have a conversation about a car driving itself? I think that would be something we would just say, well, that's impossible. And it's amazing what's being done. Okay, go ahead. So I like to look at this from a mapping standpoint from left to right. To the left, you see the old, smokestacked industries, very manual. In the right, you see the Industry 4.0 that I just described. Think of it as an internet, interconnecting, collaborative machinery, digitization in its full extent. Fortunately, today, you'll see some of that. And at MicroPack, one of the things that I did is looked at the data analytics on top of the automated robotics and put a star where we are in terms of that advancement, just because of the nature of our business. First of all, in manufacturing, an enterprise, resource planning system across the board is really critical foundation to get started with the analytics. And then once you have that and you have equipment and measurement techniques, you can move pretty far to the right with smart factories. And the bottom side of this, and kind of what kind of goes with it, is the ability to move from just automation to pure robotics. And the application of feedback loops within the automation that will drive your behavior of your robotic equipment. We'll hear some about that with the other two panelists. So, what I would say, what I want to leave you with is you deal with your companies that you're dealing with, particularly, as you may be in the accounting side or the finance side, but try to get a handle on where is that company in regards to this map, and why are they there, and where do they want to go? So the question to be asked is where are you, in your company, and where are you going? Okay, that's the action item. This is an example of something that we did. It's been a couple years back, but we have we have part that we built here. This is a relay that's used on the Patriot missile system, and on the left is a manual process to build it. And we were only able to build 1,000 a month with a lot of people. And we looked at this and said, we really need to automate because our volume and demand was going up. And so what do we do? Well, you see some pictures there. We put in automation across the board, particularly when doing the wire bonding process. It's all now automated by a robotic computerized equipment. And on the right side, you'll see, we call it a datacon. It's a piece of machinery that does the pick and place of those ICs onto its location. But look at the difference between a manual built part and an automated part. One of the things that people don't realize is you just can't take something you build by hand and put a robot in and do it automatically. We had to redesign this part for automation. So we talk about design for manufacturing. We talk about design for tests. We always use these terms. Design for automation is something that's coming up new, I think, and in fact, probably will become a buzzword because we ended up designing the package and the substrate into one single element here and provided efficiencies in the way that we built it. We had to do this for competition. We were priced too high, and it was a high volume demand. And you can see we went from 1,000 a month to 75,000 a year capacity. But look at the costed BOM. You know, we got the bill of materials is BOM. We got that, you know, down by a third easy. So that's an example of what it takes to get from a manual process to an automated process. It's not as simple as just buying a robot and making it happen. Go ahead, next slide. I like to also give everybody an action to think when you work with your companies. In a manufacturing company, this is the value stream. We talk about value streams a lot, but this is the high level value stream for anybody that takes raw material, converts it into a product, okay? And it involves the business capture, the design, fabrication, test, ship, and all the materials, raw materials that enters into it. We are seeing in our industry a broad application of this industry 4.0 in pockets that you might not think would be available. A lot of the 3D manufacturing I talked about is done up front today. You can see it starting to creep into the production fabrication world as well. Robotics is really, really moving fast in the shipping side, as is data analytics. I mean, just look at Amazon. You know, you don't have to look very deep, very far to see pockets being implemented. So this is a way to look at it from a company's through the lens of the company itself to see where opportunities reside, both in automation, robotics, as well as data analytics or data processing. A good example is in material handling. You're seeing it where you have a completely lights out robotic operation in warehouses now, things of that nature. Some of that equipment that you see is actually my equipment that I purchased. The Keonce, it's a camera that uses a microscope to do inspections and things of that nature. Okay, next. So everybody answer that question quickly. I wanted to show you an example of how we have implemented a robotic application with data as well. And this is an automatic hand-built. When I say hand-built, it was built by Micropack with an engineering consulting firm. What it does is the parts in the upper right, they're about the size of your little fingernail, and they're visible LEDs that are used in very high rel applications, high reliable applications, and they're in panel mounts. The upper left of this picture, you'll see the markings that we have to do. We have to mark these per military standards, and they're coded and marked accordingly. Here's what we used to have to do. We take one of these little parts. We have to buy a set of dies, you know, to do the markings of the whatever we're going to mark. We roll it in ink, and then we roll it over the die, We have to put it in an oven to cure it. Then we have to take it under a microscope and inspect it. And then we have to put it in the package. A long process. You know, we had 60,000 of these on backlog. Just almost impossible to do all that by hand. So what you'll see here is this robot, and I'm going to go to a movie here in a minute, and hopefully you'll get it. Depends on, you know, it's not too jagged, but it'll go pick a part out of this matrix, load matrix that we have. It'll take it over and take a laser and do the marking with a laser system. It's all programmed. And then it'll do an automatic inspection with a visual inspection system. It'll pull it out and it'll locate it we have it set up so it'll pull a tray and put it in a way in a package. In this one, it was an earlier video, we're putting it into the blue. If it goes into the blue bucket, it's a good part. So with that, and you'll see, before I leave, you'll see all the handheld, almost iPad-like operation that you can hold in your hand as you go through. If an operator wants to change the programs, we have it programmed for depending on what part class it is. So go ahead and hit the movie. So you see that it's grabbing now the part, knows exactly where to go. It indexes from there. It takes it and puts it into the laser itself. It marks it with the laser and does the visual inspection. That's what it's doing right now. And once it passes inspection, or if it doesn't, it puts it somewhere else. But if it passes inspection, it'll put it in a place. Now in the future, that'll put it in its packaging container, and it simply goes over and repeats the process. So I'm going to summarize real quick, and particularly I want to convey a message. I know, you know, return on investment in the green on the left, the boxes on the green for both the automation and the data analytics. We always have to do that, but it's not just about, be careful about relying only on the return on investment. Look at the quality impact that you have. So if you look at robotics that we just saw, it improves the quality because it's consistent, it's repeatable. It moves the workforce skills where they belong, up the ladder. We pay the skill levels are higher. We pay higher pay scales. It helps solve the $15 an hour problem, you know, those kind of things. And it's really good for the employees because they get to do more higher skilled activity. These robots that you just saw, that one that you saw that I showed, it's about a $30,000 to $35,000 universal robot. That doesn't, you know, you have to pay for I had to pay for the laser and everything else to integrate it. But lean principles, the throughput flow will improve significantly. One of the things that you always see in the value stream is flow and variations. And anytime you can increase flow and anytime you can decrease the variations in a process, you know, that's all Six Sigma going to help you. So that's what you want to do. Ergonomics and safety is really important. A lot of carpal tunnel occurs when you start repeating some of these operations. And finally, I'd like to say that, you know, the technology is arriving to us faster than we can swallow it, which is good news. On the data analytics side, the whole problem of data to information conversion exists. It always exists, but right now the data is exceeding the information, and that's what we're doing. You can reduce your overhead cost significantly because in this case, you know, the inspection's done, and a lot of the things that you have to do with people can be more efficiently done. And last but not least, you know, cash flow is really a big, you know, cash is king, right? So cash flow, meeting loan governments, covenants and things. It's important that we optimize our inventory. I didn't talk about it, but in the supply chain management system, this is where you're seeing a lot of this being implemented to be very, very efficient in the not just the just in time, but it's that kind of approach where you can, through the automation, you can get there much more efficiently. And instead of having cash in a warehouse, you have cash in the bank, and that's always good news. So it all kind of works together, and it does move the needle. I'll go ahead and move on to the next part. It's okay. Thank you.
Yeah, go ahead, Clay. Then we'll be hearing from Clay here next. Let's take it away, Clay. Thanks.
Mark, I think all the principles that Mark mentioned there on the last slide fall exactly into what our end users are trying to do as well. Sheet metal manufacturers are in a competitive environment, where their parts get bid out by all different parties, and they care about lead time, the cost of the part, and the quality of it. And so everything that Mark just mentioned on his last slide is exactly what the company that we represent, Trump, tried to do here in Chicago. It's an interesting concept, and it was a pretty significant investment, but I think the investment that they made in this facility kind of highlights the importance of where this market is going as far as automation and interconnected machines. So just a little bit about who Trump is and what this facility is. The largest manufacturer of industrial machine tools and laser technology. They manufacture cutting machines like what you see in the top left, all the way to lasers that mark components like what Mark showed, as well as lasers for eye surgery, lasers for welding, things like that. It is a German-based company, but they have a headquarters here in the U.S. As a company globally, they did 4.3 billion, so they're a pretty significant company. We supply machines from top-tier OEMs like General Motors, all the way down to small job shop contract manufacturers that have 5 to 10 employees. So that's a little bit about Trump. Lance already introduced me, so we can head to the next slide. It was built as the Industry 4.0 should be applied to machine tools. I think Mark did an excellent job about explaining the 4 revolutions. And now we're on the interconnected machine phase. So this is in Chicago. If you're really interested, I put the YouTube link down there for you. Also, if you just YouTube Trump Smart Factory, which is listed there in the top left, it'll be the first video that comes up as well. So that's an external view. We can go to the next slide. And this is an internal view, and this will make a lot more sense as we get through this. But basically what you'll see down the middle here is a system that runs the building. And all of these machines and softwares are all interconnected. Everything talks to each other. And this facility is really the state-of-the-art facility for this type of equipment. So we'll head to the next slide to see more of this in detail. So in our world, the way that we see Industry 4.0 is interconnection of machines, cutting and bending integrated. 90% of the shops out there have a cutting station and a bending station. They're not integrating a cell concept. Somebody's driving or handling parts, which is wasteful. Robotics, Mark had a great example of that. For us, we want robotics sorting parts. We want them handling the parts and welding them. Those are traditionally manual processes. Real-time production planning is a big deal. In the 80s, there was a lot higher volume jobs and less part job numbers. Now we're seeing a lot more just in time. The big OEMs are pushing the suppliers to be more competitive on lead times. So you can't do inventory, they want it, right away, and they don't want to pay for that. And production planning is critical. As far as data analytics and big data, cloud machine monitoring and service is definitely here. We're using some really innovative tools to actually pull data right off of the machine and analyze that data using artificial intelligence. I'll cover that in that slide. Track and trace, tracing parts and knowing where they're at in your factory, not letting people put a pallet in the wrong place, and having that transparency is a big deal. And then you'll see autonomous guided vehicles as well. I think that's kind of along the lines of what Mark said about when you thought about a car driving itself, everybody would have said, oh my gosh, that's impossible. we have forklifts that are driving themselves now, which are a highlight every time we do the tour. When you see a forklift just going down past you with parts, it just, everybody loses it. So those are the bullet points, and we'll go through and show you some examples of each now. So next slide, please. This just shows you what a sheet metal shop looks like. So you can see that an operator manually loading a piece of sheet metal on the left here. And then on the right, you see a traditional type of parts storage where, everything's stacked up. There's employees that are moving all around, and those guys are completely dependent on the operators. So, some of you guys may have never seen a sheet metal shop. So I just wanted to show you kind of a more conventional shop here. We'll head to the next slide. So this is the concept that you'll see basically at the Smart Factory, where down the middle row, you have all of your material and your finished parts storage through the centralized hub. And then on each side of that, you'll see different machines pulling and doing their respective features to that raw material to get to the finished parts. And then the dots and lines are supposed to symbolize all the connections. So all of the machines are talking to each other. So when machine 1 signals to machine 2, it's done. And then we have a centralized hub from programming on the right-hand side. So, and then on the left, you'll see the AGV there. So this is the smart concept, and you'll see that through each machine as well. So we'll go to the next slide. So going back to the Smart Factory here, now that you've actually seen that, that picture there, that's actually exactly what we have here. So we'll go to the next slide. So for example, the robotics and part sorting, bending, and welding, we have robotics actually picking up the parts that are all cut, and they're being sorted onto a pallet. That's what you have in the top left. Before, you'd have operators that were literally shaking parts out of sheet metal, which is definitely not safe. You can have cuts, very time consuming, and you're completely dependent on an operator. So we'll sort the parts, and then parts will come into a robotic bending cell, which is in the middle. And you can see the pallets with the raw material or cut parts. And then the robots will actually has a vision system that'll recognize how those sheet metal parts are positioned, and then go through the whole bending process. It'll set it down in stacks however you want it. The bottom right is the actually robotic laser welding. Welding has always been a bottleneck for sheet metal. Laser welding, the robotics to it, makes it almost a completely finished part. Lots of cost savings without having to grind and do all that. So all of these machines are communicating, and we're using robotics and all of those to show customers how they can do that. One of the biggest challenges in our industry is not necessarily the cost of labor, but even finding labor. We see a huge trend with kids in school today wanting to learn Photoshop and not drafting, and it's just really hard. So this is becoming a necessity in our industry. So what's unique about this is with our real-time production planning, we're actually pulling data straight off of the machines based on real-time conditions of the machines. We have a cloud system that actually analyzes that data and puts it into a very visual friendly format here. And so this top picture shows that for this whole system that, historically maybe would have had 20 or 30 employees, we're programming it with 2 employees, and we maybe have 4 operators total. That programmer can see in real time exactly what's on the machines, and they want to know everything about the machine downtime, if it has any errors, and all that's being displayed in these data boards that you see on the bottom right. So this is something that is definitely a paramount importance to our factory. Next slide. Cloud-based machine monitoring and service. Monitoring is a big deal, especially when you put robotics on it. If the machine stops, you do want to know that it stops. Now we have, iPad apps like what you see in the top right, or top left rather, that will show you the machine uptime, what's my utilization, You know, a lot of these machines are several $1,000,000. So the ROI is critical to and having those targets and that visualization so that you don't miss a 6-hour window is critical. So that's what our monitor software does. Machine predicted maintenance is one of the cooler things that I still like. These repairs on these machines can be very costly. We had a customer in Nevada who had a third shift operator that was just crashing the machine over and over and over again. And we're pulling this data off of these machines, and actually we've classified the significance of the error codes so that we can basically proactively say, Mr. Customer, your machine has had 5 of these error codes over a 24-hour period. You've really got to address this. Otherwise, you're going to cause long-term damage to the machine. So it's actually a predictive maintenance, and that's not a fee that our customers pay. Like we can go online right now with our cloud-based system, and our service department can see like what machines are down and red or green pins without even the customers calling in to service. So that's been a pretty cool new smart technology. And then on the smart glasses for virtual service, these machines are complex, and sometimes the problems are really simple. So we rolled out a new smart feature with these glasses where our service techs can actually use the glasses to see what the operator is looking at, and then we can guide the operator through how to fix the machine if it's something that can be fixed, or maybe if we can just get further down the troubleshooting process. So this is something that actually happened pre-COVID. Virtual, you know, blew up last year, but we were actually doing this the past 5 years now. So that's another smart service that we think is really beneficial. And this can be used for so many different areas beyond just machine tools as well. So, next slide, please. This is a new feature as well that's blown up. It's called track and trace. And so a lot of factories don't want to lose parts. They don't want to lose, you know, if you have a part and you got to ship it, then you got to make another one. You know, it's just straight off the bottom line. And so with this local GPS network and these track and trace units, you actually drop them on the pallet with your job. And so you can pull up the job number and then go to your computer or your iPad, and you basically have a virtual factory there where you can pull up a job number and see exactly where it is in the factory at any time. So this isn't tremendously popular yet, but this is definitely on the horizon. Obviously, if you have a lot of pallets in your factory, you may need a lot of those, but this is really, customers really like the fact that they can see that. And that, again, that transparency between the finished product and somebody in an office in real time. Next slide. These are the ones that get everybody. As you can see here, the forklift is driving totally unmanned. We use that same local GPS network that we use to locate those parts. And the AGVs actually communicate with all the machines, and they will arrive at the machine, pull parts out. They'll take it and put it in a storage facility or a storage area. An infinite number of zones in your factory, and these have really come on in the past probably 2 years. And the integration of the machines to our software really started it. And then we got the AGVs integrated to our software as well. So now we have one platform that'll enable, you know, full, you know, automation in the facility. So this is something that just blows people away. And it's obviously, you know, a sign of what's coming. So that just gave a quick tour on it.
Yeah, thanks, Clay. Before we get started, just wanted to touch on a couple things. So we actually own the bending cell that he showed, and then 2 fully automated cutting, 1 laser and 1 laser punch combo. And so and a cool story is how this smart factory can serve its clients. We had our laser down, and we had a hot order. This is back in 2016 when everything was just going crazy. And we actually doubled our sales over a 1.5-year period while only increasing our our employee count by 20%. But our machine was down, and we contacted Trump and sent them the files, and they ran the parts in Chicago and had them drop shipped to us within a week. And so it was really cool. And just having been there and seeing the automation is really inspiring. Watching the AGV, basically like a forklift, automated forklift driving around is just incredible. And we also have the smart glasses, so we utilize that virtual aspect as well to help, and that saves you from having to pay thousands of dollars to have a technician come down. And also the monitoring, they've contacted us and say, hey, we noticed this is getting low. It looks like you needed a PM right now. So just really cool stuff. And I can speak to it that what he's saying is not just, it's being done. It's very, very cool. So thanks a lot, Clay. That was really good. I also posted the video in the chat box, so there's a link there for people to watch it later. So with that, I'll hand it off to Chris. Here you go.
Thank you, everybody, for having me here. Just a little bit before we get started, I'm a third generation owner of a contract manufacturing machine shop, as Lance said earlier. And with that, as he mentioned, it's more of the antiquated thought about production. And even though we do some amazing things and we do a lot of high complex work, when I came into True Velocity, I was able to apply a lot of the disciplines that I'd learned becoming a TQM certified trainer, because we had a blank sheet. And we really got to change not just a product, as you'll see, but really the method of making that product that hadn't been changed in over 150 years. So with that, I'll let you, if you can, start the video.
So Kevin and I met through another investment opportunity that he was involved in. It was a big energy play up in Wyoming. Invested with him, and we got to know each other and become friends. And then he told me about this bullet idea, the cartridge, and said that he had come across it and gained the IP on it. And he knew my manufacturing background, so he said, hey, do you think we can make not millions but hundreds of millions? And I said, absolutely. So he showed it to me, and I said, I'm wholeheartedly in. This is a schematic of the line. Just on legal pad, hand scratched, cycle times. Lonnie and I sat down and I picked his brain on his production thoughts, getting to bring in my production thoughts. How would we do this? How are we going to inspect that? What do you think we're going to, what technology do we want to bring in this? Because we got a blank sheet. Not that it's always been easy, but it's been a joint effort, and everybody stay focused on the end game and the end goal. And we've achieved that. We've achieved what we theoretically put down on a piece of paper 5 years ago, 6 years ago, and now we're making product and shipping it out the door. I'm proud of that. We have the capacity here to have about 23 lines, which is roughly 600 million rounds a year of various calibers. Well, how are you going to move millions of pounds of powder? How are you going to move millions of pounds of projectiles? How are you going to move millions of component parts from cell to cell for the production process? Instead of building out space laterally, we're going to go up. We're going to use the unused typical spaces in manufacturing facilities and do rail lines and monorail systems throughout the plant that deliver the work in process. They deliver the finished goods to a dense cube storage system, which is that's where all of your inventory is controlled. all of your quality is there and maintained. So that's kind of the vision of how we're going to do this. More automation, more robotics, and be able to create, 600 million rounds in a 66,000 square foot facility is by doing it with new technology and a new vision and not getting, the antiquated methodologies in here. I consider this a life critical item. It's no different than an airplane engine part that makes sure that engine flies because my daughter or my son or my mom or my wife, more importantly, might be on that. So it's got to be right every time. There's no chance, it cannot fail. Or a medical component, it can't fail. Lives depend on it. Well, our product in the hands of our warfighters, in the hands of our law enforcement officials, it's got to work every time. It cannot fail. It can't fail. I think the next 18 months are going to be just light years ahead of where we are now. When we created this, we created it knowing that once this gets adopted, we're going to have to be able to deploy production cells quickly. So, a typical brass line may take 2 years to get built and put in place. We can do one in 6 months, and then we can just replicate it. So, we really did a lot of risk mitigation up front, knowing the time to get to that point was going to take a long time from the adoption. But then what happens when you get the adoption? Well, you've got to be able to answer the mail. So I think all of the work that we've done prior to this has put us in this place to be able to really capture the market and then to expand our capabilities to answer the market very rapidly. I think what makes us the best, though, in my mind, it comes down to the people who are making it, because they believe, they're passionate, they understand the benefits of this and how they can give back and support, the end user, which is our best and bravest, our warfighters and our law enforcement officers.
All right. If you can go to the next slide. As you can tell, we use robotics as much as possible. Our delivery mechanisms are non-human touch. We're currently controlling all of our raw material deliveries and water and air to the machines via vacuum tubes. Obviously, this is a product that is quite critical. It has to work, as I mentioned in there, but we also have to make money doing it. So I always like to ask the question, think of an industry or a product where it has been done the same way for 150 years. And that's what brass ammunition has been done. Current accepted scrap rates in the brass market are around 30% fallout. And a typical EBITDA, maybe 5 to 8%. With what we have done, we have shrunk the footprint by over 90% of the typical brass line. And we have shrunk the OPEX, or the number of operators, by over 90%. So in this one manufacturing cell that you can see on the bottom right, which is we call it our Generation 1 cell. I can run that cell with 2 people per shift and make roughly 27 million rounds a year. So with that line will pay for itself in about 4 months, a complete line. And a complete line costs roughly about $10 million. So you can kind of do some math and figure out what we've done is pretty unique. Now in the model of TQM, or continuous improvement, we now have a Generation 2 line. That is actually making our 50 cal rounds. But in that vein, we've taken what we've learned over the last 3 years from the Generation 1 line and the Generation 2 line, and we're now already operating in Generation 3. So what that means from a productivity standpoint per square foot is we will almost double what we originally anticipated doing in this facility. Now with the Generation 3 line, we think we can get roughly 850 to 900 million rounds a year of productivity in this floor, in this current footprint. So, you know, wrapping this up, automation, analytics, by the way, every one of these machines runs basically unattended. And that's why I can do it all with 2 people. We run with SPC, or statistical process control, and that data analytics informs us ahead of time if we need to do a PM. I'm sorry, does somebody have a question? So that, again, that saves costs, saves scrap, saves downtime. Plus, I'm able to watch from my office or my phone and know exactly what is going on. We use real-time software as well. But the non-contact inspection methods Mark King mentioned earlier, Keyent systems, we have multiple Keyent systems running throughout our entire facility. Because the vision system works much better than a human eye, and allows for greater productivity and greater predictability in terms of, you know, what we need to prevent, but also knowing what our margins can be going forward. So that's all I have on this.
Thank you, Chris. Yeah, and something I'd seen in his previous slides was just the improved accuracy. He talked about the improved quality in terms of scrap rate, but his bullet is actually, in terms of minute of angle, it's about half what the best bullets in the world are. So right. Just it's just incredible, the product that he's able to produce. Very, very innovative, and one of the most innovative minds in the industry. So just very cool to have you, Chris. Thank you for sharing all that.
I'll give you an example from a best practices model. One of the key things to that accuracy is the powder drop. And we measure powder drop in terms of grains. And we took a methodology from the medical industry, and we applied it to dropping powder. And we're able to drop powder to a 1/10 of a grain accuracy. Wow. In production. So that gives us single-digit standard deviations in velocity that allows us, you know, most of the time you have to have a hand loader, and literally they're looking through a microscope with tweezers picking out a single grain of powder, which is about the size of a, you know, grain of pepper, in order to get that magic unicorn of single-digit standard deviation. But by applying these principles and continuously improving and looking at best practices, we were able to get that in production, which, you know, nobody thought we could do.
That's incredible. Absolutely incredible. Thank you for sharing that. Very insightful. Frank, do you have a question? It looks like I think you raised your hand. No, I guess not. Looks like Robert.
Can you hear me?
Oh,
hello?
Yeah, go ahead, Frank.
Yes, I'm a hunter, and I have a 7mm Magnum rifle for big game. Are you planning to get into that caliber?
We will move into those calibers later. Right now, we're concentrating on 473 bolt face, so your 6.5 Creedmoor, 6.0, 308, 7.62, because a lot of that is a crossover with the military. We have our new 6.8 round, which actually has a 300 Win Mag capability, but with the weight of a 5.56, and also 50 caliber. But the more niche, I'll call it, calibers like 7 Mag, which I shoot as well, we will move into that at some point as we start going more into the commercial market as well.
I would be thrilled to see it. Right now, I use Hornady precision hunters, which are good, but this looks really interesting.
Yep. Yeah, one of the other things too, because of our technology, we're an insulator of heat. So we don't put heat into the chamber. If you were here, I could take you in our shooting lab and have you run a 200 round belt through a 240 machine gun and stick your finger in the chamber. you'd probably decline to do that, but it is capable of doing it. It's very cool to the touch.
Yeah, that's amazing because here in Texas, it gets hot. And when we're target practicing, we have to stop and cool the barrel off.
Sure.
So yours would dissipate the heat a lot better?
Yes, absolutely.
Where is your factory located?
It's in Garland, kind of off of Forest Lane, Jupiter, Shiloh area.
I may come see you.
Be more than happy to show you around.
Super. Thank you.
Lance, if I could be 30 seconds of a proud chamber guy.
Yes, sir.
And seeing Chris evolve into this, I mean, the ramifications of this are huge, and we're probably violating some Official Secrets Act to talk about. When you have a new kind of ammunition, you also need a new kind of weapon, and you also have the need to manufacture and do all those kinds of things. But the integration of 3 generations into a community, and Dr. Tran is here. She's the Vice Provost for Manufacturing Industry and Technology for Dallas College, and she's already talked to Chris about internships and just this whole connectivity. So besides productivity, it's importance to a bigger picture. So I just want to publicly say to Mark and to Chris, thank you. Clay, no disrespect. I just don't know you as well, but you're a good guy.
Yeah.
Paul's biased towards his Garland peeps over there.
It's an occupational hazard. Got to do it.
I do want to address one question that Robert Morris had. I believe it was directed towards Mark. I think that everybody could probably answer this. So he said, as to cash flow, are you buying or leasing the robotics? So I'll let you answer, Mark.
And we buy our automated equipment. We try to standardize on a lot of our automated pick and place robotics, our wire bonding processes. And because of our uniqueness, some of that needs to be tailored in some way that it usually becomes ours as well. So, of course, we've been we've had plenty of cash in the company to invest in this. Therefore, leasing was not something, it's something you could do, but it's not like I'm buying an off-the-shelf robot and using it to lease it. I've got to do some special fixturing. And as I said, design for automation includes how you serve the parts to the equipment has to be designed special as well. So the fixturing and the drive systems that you put with it and everything. So for us, we buy our equipment. That doesn't mean that you cannot lease. It's an option that you can do.
Yeah.
No.
Sorry, go ahead, Chris.
No, we do the same thing. We buy the equipment.
Yeah,
And it's very easy to capitalize. It's very easy to capitalize, including any labor that you put into it to develop it. So, that's the other thing that is the advantage from a cash flow. The cash flow hits you, of course, but from the P&L side, you capitalize it over a life of the equipment.
Right.
Yeah, and also with the Section 179 and bonus depreciation methods, it makes it really attractive to purchase the equipment. Of course, you can still take those if you structure the lease the right way. So, but yeah, we as well purchase all of our equipment. We have done some lease to buy as well, so that we can still take advantage of the Section 179 and bonus. Any other questions?
Yeah, if you can pay for your equipment in 4 months, that makes that easy.
It really does. It's nice.
Yeah.
Yeah, with all these finance people, I'm sure they're drooling over that ROI. Wasn't tough to do the numbers there pretty quickly. It's pretty incredible. Anybody else? Looks like that's all the questions. I'm sure we could all talk guns all day, but especially with this ammunition shortage, man, what a time to get into that industry.
Stay tuned.
Everybody's trying to get their hands on ammo and can't even buy it. It's pretty crazy.
Nope.
Well, thank you guys so much for your time. I know you all invested quite a bit of time preparing for this and setting time aside to present. We really, really appreciate you.
Great stuff. Thanks, everyone.
Yeah, thanks so
you.
much, Lance. Appreciate it.
Thank y'all for having us.
All right.